Hello guys, I hope that you had a great day today. We want to go over a problem in calculus regarding the chain rule. Hussein helps me solve the problem. The problem we have is actually we have on the numerator e to the power of e to the power of pi to the power of x, and on the denominator we have pi to the power of square root of x. So Hussein will use the chain rule to solve this problem. Hussein, please go ahead. The floor is yours.
Hi everyone. So as Amir mentioned, I'm going to use chain rule for this problem. I think as a reminder, I wanted to write down on the side the derivative rule for exponent. So if we have y equal a to the x, then y prime is equal to a to the x ln of a. And then in general, if we have y equal a to the u, which u is a function of x, then y prime is u prime a to the u ln of a. Is that correct, Amir?
Yes.
Okay. So I'm going to use these rules to solve this problem. So I think I start by calling pi to the x as u. So u is pi to the x, then u prime is pi to the x ln of pi. Then I'm going to call e to the u or e to the pi to the x as v. So v is a new function of x, which is equal to e to the pi to the x or e to the u. Yeah. Then v prime is equal to u prime. Let me bring this down a little bit, so I'm running out of space.
Yeah.
So v prime is equal to u prime e to the u ln of e, which is 1. So this is 1. So I have u prime e to the u. And then so eventually the whole thing on the numerator is w, which is a function of x again. So e to the pi to the x is equal to w, and then I can rewrite it as e to the v.
Yeah.
And exactly the derivative is the same as what I did on the line above. So w prime is equal to v prime e to the v. Now I'm going to...
Hussein, there is a point. V prime is not a derivative in terms of x. It is derivative in terms of u. So it's good to just write it down in front of the line. V prime equals dv over du. So
yes.
I mean, yeah, just like in a bracket in front of at the end of each line. So it cannot, it is not confused with x.
So dv
dw.
Is that what you mean?
I meant for the line above, and also line. You know,
the line.
I mean, yeah, it applies to both lines. V prime, W prime. V prime is in terms of u. Yes, yes, exactly. And the line below is dw. Yeah.
So it's dw to dv.
dv, correct, yeah. Just to be clear, v prime is different from u prime. U prime is in terms of x, du
Right.
over d. Yeah, thank you.
And so I'm going to plug in the value of v prime and u prime from the equation that I wrote on the first line and second line. So w prime is equal to, so this v prime, I'm going to use this expression on the line above. So u prime e to the u e to the v. And then for this u prime, I'm going to use this expression. I'm going to replace that. So I have pi to the x ln of pi e to the u e to the v. Then I can make it more complicated by replacing the u and v with the actual values. So pi to the x ln of pi, then this u, I have it here in terms of x. So I have e to the pi to the x, and then this v here, where is it? I think I wrote it here.
E to the, correct, yeah.
So this is v. So e to the e to the pi to the x.
That's correct, yeah.
So this is w.
Yeah.
I'm sorry, this is w prime. And now I'm going to, I think I'm going to move to the denominator and find the derivative of that.
That's correct.
So in the denominator, I have, here in the denominator, I have pi to the square root of x. So I'm going to call this a square root of x as, you name it. I'm running out of characters.
Like m, like mother, m.
M, okay, m. So m is a function of x. So m is a square root of x, then m prime is 1 over 2 times a square root of x.
Correct.
I hope I didn't confuse everybody, because x, if you have x to the n, then let me see. If you have y equal x to the n, then y prime is n x to n minus 1. And then I use this rule to find this derivative. I'm not going to get into the detail of that.
And here is 1 over 2. Yeah.
Right. Yeah, n here is 1/2, 1 over 2. And then what did I have? So I have pi to the square root of x. So I'm going to introduce another variable called, let's call the whole thing f, for example.
Yeah.
Then I have f equal pi to the square root of x, or pi to the m, and then f prime is equal to, going to use exponent rule here. So it's going to be m prime pi to the m ln of pi. And then this is df, I think df to dm, right?
Yes, correct.
So this is going to be df to dm.
Correct.
And then I think I'm going to, at this point, I'm going to replace these values that the m prime, I obtain it up here.
Yeah.
So f prime equal to 1 over 2 square root of x pi to the m. M, I have it here. So pi to the square root of x ln of pi. And this is the derivative of the denominator.
And the derivative of the numerator is w prime, which is in terms of x. W prime here is dw over dx.
Right, here I have dw over dx, and here I have df over dx.
Yeah.
And then
So
if I go back to the, pardon me?
Yeah, I mean, I just wanted to complete. Yeah, since we have both the derivatives of the numerator and denominator, then we can use the derivatives of the fraction, you know, the rule of that to obtain the final solution for the problem.
Right. So if I go back, the original g of x is a fraction. So g of x. So on the denominator, I have f prime, not f prime. I have f, and then on the numerator, I have w.
Yeah, you're rewriting the equation. Okay. Yeah.
And so if you remember in our previous videos, we talk about quotient rule. So I'm going to use the quotient rule here. And so as a reminder, G prime, the quotient rule, based on the quotient rule, I have W prime times F minus W times F prime divided by F squared. This is the quotient rule. So if I use this here, I have W prime, I have it up here.
Yes.
Pi to the x ln of pi, and then e to pi to x, then e to pi to x.
Yes, that's W prime.
Yes, times f, which is f is pi to square root of x.
That's correct.
Pi to square root of x minus w, which is, yeah, w is e to the pi to the x times f prime, which is 1 over 2 times a square root of x pi square root of x ln of pi, then divided by f squared, which is pi to the square root of x squared.
That's correct.
And then I don't know how much time I have. We can.
Yeah, I think.
We can, go ahead and maybe simplify it a little bit further, but this is the derivative.
Yeah, that's a derivative. They can cancel out pi to the power of the square root of x from denominator and numerator, and it can be simplified. I mean, I think that's enough up to this point, and viewers are aware of just algebraic expression simplification.
Yeah.
So, thank you, Hussein.
No problem.
Explained the chain rule, the nested chain rule. We used the chain rule twice for the numerator and the denominator just once. And we obtained the final derivative based on the quotient rule. So hopefully viewers learned something from this video. If you liked it, please subscribe to the channel and hit the bell button. And until the next video, I hope that you will have a great time. Thank you.
Thank you. Have a great time. Bye.
Bye.